Back. I actually read Catcher in the Rye. I think in the last video I was like, yo, I actually need to read Catcher in the Rye. Cause like, or else like my English people will get mad. But like, I actually read it. It's not even that bad. Like, it's actually really funny. Like, I'd actually recommend it. Like, genuinely. Alright, anyway, I'm back with this Jan Calda problem. We're in the big boy league now. Jan Calda, oh my god. I didn't think I'd ever make it here. Yeah. But you can read it. I'm not gonna read it. Um, I to be totally transparent with you guys, I actually read the solution for this on Everest, but the issue was like I think I was too stupid to understand the solution. I actually like so many questions. I was like, wait, why did they do it like this? So, I spent like my English class, like instead of doing my English work for Catcher in the Rye, I decided that I'm gonna spend it on solving this problem. And I actually found like a really good solution. Maybe it's been covered, maybe it's been not, but to be honest, this solution is like it's more computation, but I think you will understand it better because I honestly don't understand the other solution. So I'm more confident presenting this solution. Hopefully that was enough time for you to read it because I think I was just yapping away. But whatever. Okay, so we're gonna get started. So the first thing I'm gonna draw is this surface here. I'm gonna draw it, and basically what this particle does is, yeah, it moves like this, and then adds like a 3D picture that I'm gonna draw. That looks a bit wonky. Beta, alpha. Yeah, I think that was like the most difficult part of the problem actually. This, just understanding what it meant. But yeah. So we have this graph, which is the equation of the projectile, and basically what we're gonna do, it's gonna be pretty similar to the thing that we did in 1D kinematics, like the graphing problems in the beginning, if you still remember that. Like basically we'd write the equations and then figure out the graphs and then set them equal to each other. We're gonna do something similar here. So first thing to do is to write the equations. X equals VO cos beta t, and y equals to VO. Sorry, almost forgot that. Sine beta t minus 1 half g sine alpha t squared. And acceleration is going to be equal to g sine alpha. If you don't understand that, honestly, I don't even know. Just go back to ABC 1 to 1. I don't know what to tell you. But yeah, it's not even to be mean though, but like I'm just being genuinely like honest. Like the problems will only get more difficult from here. Like like you should actually just work on foundations, in my opinion. So yeah, we're gonna solve for t x over VO cos beta y equals O sine beta x over O cos beta minus g sine alpha um x squared all over 2VO squared cos squared beta. I think that's right. And then y equals to x tan beta minus g sine alpha x squared all over 2VO squared cos squared beta. Okay, and we're trying to find alpha. So what this gives us is the equation of a projectile, which we can line up to this. We can line up to this. This is also the equation of a projectile. And in the equation of projectile, there's like many things, right? So this is in what, standard form? AX plus BX plus C. And here we can see that A is going to be equal to this and B is going to be equal to this. We're going to focus on A because we're not, it's B is not relevant. But we know that A equals to negative G sine alpha, G sine alpha all over 2 VO squared cos squared beta. That's A. And if you don't understand how that happened, genuinely, literally go on Khan Academy, Google AP Physics 1, and then it'll all make sense. Trust the stars will align, just trust me on this one. Don't go too quick if you cannot. pace yourself. And yeah, we're gonna find A for this question. So a good demonstration, like that I like to do is this, like to try to make it make sense. So why, let's just say we have this equation. You'll see it goes over 1 unit and it goes 3, right? Because we put a 3 here. If we do this, it goes over 1 unit and makes it 5 because we put a 5 there. Obviously, it doesn't continue forever, but it continues through the first part, which is pretty interesting. The only issue here is that it's in 2.5s. So we cannot do that. We have to resort to the vertex equation, which is what? I think it's this. Where h and k is whatever, we can actually just choose a coordinate point for h and k to be. Let's say this is at my origin now. So yeah, h and k are 0 now. I just chose a coordinate point. You can do that. It's physics. You do whatever you want to do, as long as it's consistent. So yeah, we're just going to cancel this out and get y equals to ax squared. And now I'm going to choose something arbitrary. Like, let's say I just did this. So now, like, this would be what? This is going to be x equals to 5 and y equals 2.5. 2.5 equals to 5 squared a. And that's going to be a equals zero point 0.1. Yeah. So we're just going to take this a value and then set it equal to this. Yeah. So negative g sine alpha all over 2VO squared cos beta equals to 0.1. I'm back. I actually just went to investigate something because I was actually pretty confused on what was up. So basically, I in the video, I said, wait, I said that we did these 2 points specifically, and I was basically wondering, what if we didn't do these 2 points? Like, why can't we go all the way here and back down here? And basically, when I was looking, I was like, oh shoot, it's because this doesn't actually cross it. Like, look at it. It's not actually precise enough. Like, it's not actually on it. So we can't do like it did. Like, we can't do 5 equals to 7.5 squared because it's not actually true because this isn't touching it. So yeah, I was just looking into that if you had like a similar question. And now that makes the other solution actually accessible for us because I actually understand that now. So yeah, I guess in this video I'll be covering it too. A double solution time. So, yeah, we're gonna do the Desmos thing first though. Um, hold up. Uh, like 10 sine alpha. Wait. 10 sine alpha all over 2 times 10 squared goes squared 60. Make sure it is in degrees and equals 0 0.1. So you do all this 50 times 0 0.1, so it's 5. Wait, look, let me hold up. So this is times 0 0.1 times 0 0.1, and you divide the entire thing by 10, and you do sine -1, and that equals 30. Whoa, and that is how we got 30 degrees. That is one way to do it. And I did mention, like, I do understand the other method now, so let's do that. So the other method was this. Here, let me show you. We don't need like the trajectory at all, actually. Basically what we do is we just focus on this graph, basically. Shoot. Yeah. So just focus on this graph and just remember this. This is very important for this. So first thing we need to answer is what is like the overall trajectory. So that's x, that's this. And we can see from this that x is 5 because it covers a distance of 5. And if we do 10 cosine 60 degrees, um, 10 cos 60, it's also 5. So t equals to 1. So it takes 1 second to do this flight path, right? And now from there, all we do is just because it's from look, it peaks here, right? V equals 0, so it's from rest. So we can do g sine theta t squared all over 2 equals 2.5. And this is going to be 1. Oh, shoot. Wait, sorry. Sine alpha 1, 5 equals to 10 sine alpha. Sine alpha equals 1/2, and therefore alpha equals 30 degrees. So that is the easier way to do it. But now we have two ways to do it. It's pretty cool. So yeah, today we took on the big boy, JAAN KALDA. Yeah. Um, I actually need to find a good outro for these videos. Like the video if you liked it. Don't like if you didn't. And yeah, I'll see you in the next physics video.